Okay, everybody, yes, we are continuing to part two, and you'll probably be wondering, um, what are we gonna talk about? One of the things that I want to talk about, is very, variadic parameters. What um, variadic parameters is like, you specify in the parameter that you take multiple, you that you can take multiple parameters of the same type. You basically specify like this, for example, like sum, and these are the arguments, and you specify like this, dot 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 triple dots. What that tells you, um, what that specify is that it can take multiple parameters. Um, like as we implement a little bit more for a in arguments. Result plus a like that, and return result. So what this interesting thing does is that when you call a sum, you don't specify how many parameters there is. In the case before, we specified two parameters. That's it. But what if you want to take like a varying amount of parameter depending on the call, like this: sum 1, 2, sum 1, 2, 3, 4, 5, like that. So you can see right here, you can call with parameters of adding 2, and or you can call it with a varying amount of parameter depending on like on your development needs. So you can see right here, it shows 15 or 3, but you just specify with 3 dots that you can take varying amount of parameters from 2 to like 5 and beyond. So that's variadic parameters. So something else like, back up here, what if you want to have a parameters that outputs, text changes and output. You can do that with in out. So you can say this for first param, like we specify. So we have this like this for goes to hello 0, like that, and you pass this in. While it's inside, let's see, what's the error right here? Right, you also have to specify this is an in and out, like so. You specify that is an in and out when you call the function. You have to specify and the calling programming line. While it's inside, when you pass it into the function, while it's inside, you can make changes to the parameter. Since inside is called a, you can say a is more, or maybe a little bit more text here, like so. If you didn't specify in and out, you can't do that to a parameter. Since you say this is an in and out, it's changeable now. And hello here will be altered, as we can display by printing it out, like so. So basically, oh, there it is. When you print it out, you see it changed from hello 0, which is specified here, and you pass this into as an in and out parameter of the do this function. And what it does inside the function, it just appends more text to it, more text here like so. So that's how you have like a mutable, changeable parameter. Another thing that you can do is just call this as a var, but this is only within. This is different. This is only changeable within the function itself. It's local when you specify var. You print a here, it will show as before inside the function. But when you print it out, it remains the same. You see the difference? Hello 0. Because when you specify var, it's only a local changeable within the function, the scope of the function. As you can see here, we're inside the scope of the function is print a. So there's a little bit of difference with in-out parameters and just specify var locally. That's changeable within the scope of the function. So we review variadic in and out, and we can also specify nesting functions. So within the function, we can also specify another function. Yes, this is a unique. You can say print hello. And you escape the variable I saw. Yeah, this is how you nest basically a function. Or you can return another function as a return parameter of the outer function. You can specify like a int, b int, and so you return a plus b like so. Some unique things you can do is return a function from a core to the outer function. You specify that by basically specify the footprint as the return parameter, the footprint of the function as a parameter. You see right here, the footprint is taking an a and a b integer and then return int. So you basically can show them this is the return the footprint of the function. So you can specify as like this func like so as the name of the function. And how you call a function, you basically do it like this. Let return func goes to do this first param, second param, like so. They want strings. So what this does, it returns the function of this func. Name is the name of the function right here. And once you have this return func, you can call it like it is, as specified within the function. 1, 2, like that. Or you can just print it out. Okay, just clarify. We just nested a function within a function. This is the outer function do this, and inside we implemented a nested function. We also altered the return type as the footprint of the nested function. As you can see, it's taking two parameters, int and return an int. And then return this func as the name of the function. So we just do let return func do this, parameter 1 and second parameters, and just print it out, and it shows it right here. Added both of them. As you can see, this is the implementation. So that's basically nested functions. Practically speaking, I imagine is rarely used, but you can do that, returning a function as the return. Alright, something to mention as well. Yeah, default values for parameters. You can specify it like this, equals to default string. This is when you call the function and you do not provide a parameter value, and just defaults to this value right here. So you can show it as by print b like so. Let's see what they say. Oh, so this is interesting news. They say the var, specifying var in the parameter is going to be deprecated in Swift 3. So you should just use in out, which is has the scope of outside calling function, as opposed to var, which is local within the scope of the function inside the implementation. Alright, so basically this is how you specify default values for strings. If it was an int, you specify it like this, and you change the default value to maybe like a 10 or something like that. That's how you specify default values, with an equal sign after the type specification of the parameter. Alright. Alright, so oh yeah, if you are tired of like specifying different names, external names, you want the same internal and external names, you can specify like this, with a what you call the number symbol. So well, it causes various different errors because we specify a name for it. So we do it on a different function. Do to you can specify like this: first param string and second param as string. So what this does, instead of having an external name different from the internal name of a function, you have the same name for external and internal. So you can do it like this. That returns the first parameter and second parameter. And when you call the function, you can specify like this. Yeah, so let me see. You say argument pass to call takes no arguments. So let's see, result. Do 2. We specify the function name, maybe the implementation. Well, we know that this is how you specify the function. Do func, maybe clarify like that. Unresolved, identify a second param. Sometimes it's good to copy and paste to make sure the spelling are correct. To string. So we see here, we take these signs off and see what happened. Did they take it off? Yeah, they took it off. Maybe it's a deprecated feature to see. Well, nevertheless, you can use the signs to do it, to specify it. And so, but in this case, it's certainly not needed at all. You specify first parameters as internally used and also externally specified. Do func like so. So that might be one of those features is no longer used. Experience label. Yeah, so you can specify if you want to, and you don't even need to do it at all sometimes. So we look into that. We'll get back to you on it about it. They say insert a second parameter. So we did fix that. So you can see in the second parameter, the internal and external name is the same. So definitely with the changing language with Swift 3 coming about, a lot of things may be deprecated. As in the case of the var, definitely it's stated that it will be deprecated with the var. In terms of using labels, internal, external, this is how you would do it. So again, that's why we did the multiple parts for the function implementation. All the features of the functions, you can tell you can use tubelets, as you remember, and so returning one value, you can return a pair of values. As we also mentioned, the default values, you specify after the type with an equal sign in the value in the parameter declaration. Also, we talked about the mutability of the parameters. We don't want to use for anymore, as we saw. We use in out keyword in front of the parameter first. So we show how it can be changed internally and externally. What else? Our variadic parameters, taking multiple parameters and so forth like that. With the 3 dots. And the nesting of the functions. You can actually return a function from a call to a function. Again, I believe that's very rarely used, but that's a feature that's available. You specify the footprint of the function, the function that you want to return. So, all in all, this is the second part of the functions. If there's like a new feature of Swift 3, we would definitely make a third part on the features of Swift functions. Alright, thanks for watching. Yeah.